Hello, everybody. Hopefully, you're doing well. In this video, we're going to conclude with our first chapter in this book, Fundamental Concept of Algebra. Especially, we're going to take a look on section 6. And in section 6, it's rational expressions. Rational expressions is very useful in the way we describe, for example, cost of environmental projects, right? So we use rational expressions for that. So that's one of examples we can use. But let's see in terms of objectives for these sections, we're going to specify numbers that must be excluded from the domain of a rational expression. Simplify rational expressions is one of the things we do. We're going to multiply them, divide, add, and subtract, and also see some complex rational expressions. It's not a complex numbers, but complex rational expressions. Let's see very quick in terms of definitions. The set rational expressions is the quotient of two polynomials. All right. For examples, you can see, let's suppose we have x minus 3 over 5. That's a rational expression. If we have 4 over x minus 1, if we have x over 2x squared plus 6, if we have I don't know, like let's say x squared plus 5 over x squared plus 5x plus 3 is 6. That's an example, few examples. That's few examples of rational expressions. So this set of real numbers for which an algebraic expressions is defined is the domain of the expression. That means no zeros in the denominator because rational expressions indicate divisions and division by zero is undefined. So we must exclude numbers from irrational expressions domain that makes the denominator equal to zero. So we cannot have that. So we always need, first of all, to verify what value would make the denominator equal to zero. Then we're going to exclude it before we can perform any operations on rational expressions. All right. Now, let's see few examples for which value of each of these these rational expressions would be undefined. These expressions cannot be evaluated, it would be undefined. All right. So verify what number would make the denominator equal to zero. That's the questions you need to ask yourself. What number would make the denominator equal to zero? So that's how you've performed to determine the numbers that must be excluded from each domain, right? Now, for the rational expressions in part A here, what you should exclude, what would make the denominator equal to zero? So first of all, you can just simplify like, oh, x plus 5 equal to zero shouldn't be equal to zero. So -5 from both sides. You know x cannot be equal to -5, right? So that's what it is. You said, well, you know what? I can say x cannot be equal -5, or I can simply say that, you know what? I'm gonna write it like this. It cannot be take -5. So for x cannot be -5, right? So how about b? As I said, first of all, you set the denominator equal to zero, then you solve. Okay? So if you solve, x squared would be 36. If you take the square roots of both sides, what would be x? Plus n minus 6. So that means for these expressions right here, x cannot be equal -6 and 6, right? Because that's a problem. You cannot have these two numbers for these expressions. Or if you want to do it separately, you can say x cannot be equal negative and x cannot be equal to 6. Okay? X cannot be equal -6 and x cannot be equal to 6. The same, focus on the denominator, because we already know the numerator is a non-zero number, then we gonna make sure the denominator is not zero. All right, so if the denominator is zero, then that's a problem. So you set the denominator equal to zero, then you solve. Okay, so here, remember what we just learned from factoring? Two numbers, because the coefficient of x squared is 1, we can factor this one saying two numbers when you multiply give you negative 14, when you add give you negative 5 is negative 7 and 2. Now you solve, set each factor equal to 0. If you do x minus 7 equal to 0, add 7 both sides, so x would be equal to 7. X plus 2 equal to 0, add 2 both sides, subtract 2 both sides, x would be equal negative 2. So the two values for which x would be undefined for C would be x cannot be equal 7 and x cannot be equal negative 2. Okay? So that's how we're gonna see these two values, all right? Always focus in the denominator, so verify for which number, to verify which number must be excluded from the domain, right? So we must examine the denominator to do that. So irrational expressions, what you can do with it also, we can simplify rational expressions, right? To simplify rational expression, the rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1, right? So that's what we're trying to figure it out. So the following procedures can be used to simplify rational expressions. First of all, factor the numerator and the denominator completely, divide both. For examples, if I have 2x plus 6 over I would say x plus 3, right? Well, first of all, if they ask me to do that, I look at the top one. I already see I can factor a 2. So x plus 3. Oh, look at that. I have x plus 3 at the bottom as well. So first of all, I need to set the conditions, right? Because you see you have a quotient here. So we know P over Q is possible when Q is not equal to 0. All right, so I need to make sure that x plus 3 is not equal to 0. Then I cancel out these two terms. My final answer would be only 2. Always have that conditions where you say, you know what? The denominator cannot be equal to 0. That means x cannot be negative 3 here. If x is not negative 3, then it's possible to cancel out. Now, look at these terms. Oh, I just did something very similar. So common factor from the top, because you need to factor out the greatest common factor from numerator and denominator. From numerator, as you can see, is x squared. So we have x plus 3 left. From the denominator, there is nothing. It's only 1, right? It's only 1, so x plus 3. You see you can cancel out the x plus 3 when x plus 3 is not equal to 0. That's the conditions. So answer would be x squared over 1. It's only x squared as a final answer. So we said x, remember x cannot be equal to negative 3. So we must exclude the number that would make the denominator equal to 0. Here, looking at the top one, remember a squared minus b squared is a plus b times a minus b. The good thing is we already covered section 5, because you do factoring already. If you miss it, please go back and watch this video on section 5, because we went over factoring. Now we see the top one is x squared minus 1 squared, because 1 power, not anything would be equal to 1. The bottom one, coefficient of x squared is, remember, coefficient of x squared is 1. So you're going to say two numbers when you multiply give you 1, when you add give you 2, is 1 times 1. 1 times 1 is 1. 1 plus 1 is 2. So we're going to have x plus 1 times x plus 1. And the top one would be x plus 1 times x minus 1 over x plus 1 times x plus 1. When x plus 1 is not equal to 0, so because we said x plus 1 is not equal to 0, meaning x is not equal -1, so we can cancel these two. What we have left, x minus 1. I don't need to put parentheses anymore. Over x plus 1, right? That's it. And it's really good because you need to factor the greatest common factor. Use all the techniques you learned from section 5. If you don't remember, please, I would advise you to go back and watch this video, okay? Very important. Um, Multiplying rational expressions. There are so many things you can do beside, because when you take the rational expressions, you can evaluate the rational expressions. You can find the values that would make the rational expressions undefined. That means the denominator equal to 0. You can simplify them, but we can also perform some multiplication on rational expressions. So the product of two rational expressions is the product of the numerators divided by the product of their denominators. So remember, when you have a fractions times another fractions, what we said we did, yes, we multiply the top ones together and we multiply the bottom ones together. It's the same thing we're gonna do with rational expressions. First of all, if we go step by step to multiply them, factor all numerators and denominators completely. Divide numerators and denominators by common factors, multiply the remaining factors in the numerators, and multiply the remaining factors in the denominator. So remember, do not try to distribute very quick. The first step is to factor out. For example, we know these two terms must be, we multiply the top ones, multiply the numerators together, and multiply the denominators together. Please do not distribute. It's better you're looking to factor the trinomials. I'm gonna keep x plus 3 because there is no common factor inside of this parenthesis, but I see that trinomials would give us is a product of two binomials. I mean, two numbers when you multiply give you -6, when you add give you -1. Two numbers you multiply would give you -6, when you add give you -1. Yes, thank you. It's -3 times 2, -3 plus 2. So we're gonna have x minus 3, x plus 2. That's the top one. The bottom one, remember, if you see x squared minus 4 is the same thing saying x squared minus 2 squared. What is a squared minus b squared again? If you have a squared minus b squared is what? A plus b times a minus b, right? So we're gonna have x plus 2 times x minus 2. We're done with the first term in the denominator, first parenthesis in the denominator. How about the second one? Again, the coefficient of x squared is not greater than 1 or less than 1. So we would go with two binomials, a trinomials, okay, is a product of two binomials, okay? So two numbers when you multiply give you 9, when you add give you 6, it's 3, right? X plus 3, x plus 3. Now you can set your conditions in order to cancel out. If x is not equal to -3, then you cancel these two. If x, oh, there was, what was that one again? That was a plus 2. Okay, if there is no -2 in the binomial. So if x is +2, we're gonna have x plus 2 here too. So what we have left, we have only x minus 3 left over x minus 2 times x plus 3. Okay, x minus 2 times x plus 3. And that's it. Okay, that's it. It's very important. Okay, so any questions? Any questions? Any questions? Okay, I think you're okay with that, with that one. Of course, it's multiplication. It's multiplication of rational expressions. Remember, for this one, I have to set the conditions. I know x plus 3 cannot be equal to 0. X plus 2 cannot be equal to 0. That means x cannot be equal to negative 3, and x cannot be equal to negative 2 in order to cancel out. The denominator cannot be 0, right? Now, that's an example for multiplication. How about for divisions? Because the quotient of two rational expressions is the product of, of the first expressions and the division. The quotient of two rational expressions is the product of the first expressions and the multiplicative inverse or reciprocal of the second expression. So what we mean by that, anytime we multiply two expressions, we keep the first one as is, multiply by the reciprocal of the second one. So we flip the second one and change the division sign into the multiplication sign. So the reciprocal is found by interchanging the numerator and the denominator. So we find the quotient of two rational expressions by inverting the divisor and multiplying. Okay, so hopefully you're gonna see this in the examples. Let's try that example. So the first thing to do, we need to keep the first one as is, x squared minus 2x plus 1 over x cubed plus x. Now, flip the second one, but we change the sign in the middle. So we have 3x squared plus 3 over x squared plus x minus 2. Okay? Now, after that, you remember product. First of all, you do A over B time divided by C over D. We said A over B times C over D. Remember, when you have a fraction times another fraction, multiply the top ones together and multiply the bottom ones together. So what we're gonna do here, we know x squared minus 2x plus 1. We're going to multiply it by 3x squared plus 3 over x cubed plus x, okay, times x squared plus x minus 2. Okay, now let's factor. Coefficient of x squared in the first one is 1. So two numbers when you multiply give you positive 1. When you add give you negative 2. It's negative 1 and negative 1. X minus 1 give you the first expressions. The second one, what you see, oh, there is only 3 that is common. So 3 times x squared plus 1. Done, because the 3 is a common factor. The bottom one, we see x is a common factor, so we have x squared plus 1. Then the second factor, remember, to factor trinomials give you two, the two binomials give you trinomials. We're gonna do two numbers when you multiply give you negative 2. When you add give you positive 1 is 1 and negative 2 and negative 1. So x plus 2 times x minus 1. We have so many conditions. Let's say when x minus 1 is not equal to 0, we can cancel this one. Okay. When x squared plus 1 is not equal to 0, we can cancel this too. Okay. Oh, note that x squared plus 2 would never be equal to 0. Okay, I don't even need to set that conditions because x squared plus 2 would never be equal to 0. Okay, do we have another one? No, that's it, right? Okay, remember x cannot be equal to -2 as well because what we're gonna have down there. So we have left 3x minus 1 over x times x plus 2. So x cannot be 0, x cannot be equal -2 as well. So, but that's where we get with dividing rational expressions. Because we try to do one examples of each, let's go very quick on adding and subtracting and subtracting rational expressions with the same denominator because you have it two ways. We add and subtract rational expressions with the same denominator by adding or subtracting the numerators and keep the denominators as is. We add or subtract the numerators and we keep the denominators as is. For example, if I have 2x plus 1 over x minus 1 plus 3 minus x over x minus 1, because the numerator is the same, all I have to do is add the numerators, right? And keep the denominator. Do not put the denominators twice. Do not add the denominators. Just keep it. So 2x minus x give you x, 1 plus 3 give you 4 over x minus 1. Of course, cannot be equal to 1, otherwise the expressions would be undefined. Okay, that's an example. All right. Let's try this one. You see, I take a random examples, but we have same denominator. First of all, keep it, x plus 1. So x minus parenthesis 3x plus 2. Why I use a parenthesis? Because there is a negative. I need to distribute the negative, make sure the negative is not only for the 3x, but also for the 2. So x plus 1. When you factor, you have negative 2x minus 2 over x plus 2. Oh, look at what happened. I can factor negative 2 on the top and have x plus 1 over x plus 1. Now, all I have to say, x plus 1 cannot be equal to 0. So I cancel. I have negative 2 as a final answer, right? You can verify this. That's very important, extremely important to do that, okay? Very important. That's a very simple examples. But when you add and divide, and when you add or subtract rational expressions with different denominators, you need to find the least common denominator. Okay, least common denominator. We can gain insight into adding rational expressions with different denominators by looking closely at what we do when adding fractions with different denominators. For example, if I have 2/3 plus 1/2, what is the common denominator here? Yes, it's 6. That's mean I need to multiply this one by 3, and multiply this one by 2, by 2. So that's give us 4 over 6 plus 3 over 6. Let's give us 7 over 6. Keep the denominator and add the numerator. So you look at this as we were adding. So we must first write the fractions with the same denominators. We look for the smallest number that contains both, 2 and 3, okay? And, it gives you see that number is 6. So is used as the least common denominator. We call it LCD. So the LCD, the least common denominator of several rational expressions, is a polynomial consisting of the product of all prime factors in the denominators, okay? With each factor raised to the greatest power of its occurrence in any denominator. So first of all, factor each denominator completely. List the factors of the first denominator, add to the list in step 2 any factors of the second denominator that do not appear in this list. And then you continue to do the same thing from the product of the factors from the list in step 3. This product is the least common denominator. I know giving you all those explanations once make it feels, oh my God, that's complicated. Right now, maybe we should do an examples of this one. How about that? Okay, we said that we said after you find all of this, you know what? I'm gonna insert a slide and show what I'm talking about. So if they ask you find the LCD, okay, and if you have of 3 over x plus 1 and 5 over x minus 1. So what we said from the previous one, oh, you know what? You must, first of all, keep the first denominator and look at the next one, something that the first one doesn't have. Well, the first one doesn't have x minus 1, so we're gonna set x minus 1. And it's simple, In this example, first of all, we check for the denominators. We look for the common factors, and LCD is simply the product of the denominators because they have nothing in common. But it's not all the time you're gonna find it that easy, right? For example, if we have, I'll call this one A, B. If we have 3, of course, at the end, I have those examples, but I prefer to do them right here. 2x squared minus 6x plus 9. And you have 7 over x squared minus 9. When you look at these two expressions, you cannot say, oh, you know what? We're going to take the first denominator, we multiply with the second one. No. The first step, we must factor completely the denominators. You must factor completely the denominators. So we're gonna do 3 over two numbers when you multiply give you positive 9, when you add give you negative 6 is x minus 3 times x minus 3. And you must factor the second one. Remember, x squared minus 9 is like x squared minus 3 squared. So x plus 3 x minus 3. Okay. Now, what I need to look at this one, take everything I have from the first because we said the LCD is everything you find in the first denominator. Take everything. Now, check in the second denominator the factors you not already have. Well, x minus 3, I already have it. All I need to do is add the next one, which is x plus 3. So you see, that one contains all the terms in the first denominator and all the terms in all the factors in the first denominator, all the factors in the second denominator. So that's it. Okay. So now you know how to add, find the least common denominator. You have no problem with that, right? Now, how about adding and subtracting rational expressions that have different denominators? That's what we were explaining before. To find the least common denominator of the rational expressions, we write each rational expressions as an equivalent expressions whose denominator is the least LCD. Okay. To do so, you multiply the numerator and the denominator of each rational expressions by any factors needed to convert the denominator into the LCD, the least common denominator. Add or subtract numerators, placing the result expressions over the LCD, and if possible, you can simplify the resulting rational expressions. So that's these 4 steps you need to follow. I'm going, I don't know if I have any examples here. Oh, that's what I just did for, okay, I did this one too here. So I think I had them, but you know what? I didn't write. Okay. Now, what they ask you to do here is to add. They ask us to add. Okay, note that each of these denominator has only one term. So for A, okay, you have only one term. So if you have one term, just multiply the 2 terms at the bottom. So the least common denominator for A is simply 5x. Okay, so that means how I'm gonna do it, I need to multiply 5 by x. So that means whatever you do with the bottom, you must do it also with the top. I need to multiply x by 5. That means whatever I do with the bottom, I do it also with the top. So I end up having x times x plus 1 over 5x, okay, minus 8 times 5 times 8 over 5x. Let's do it. We have x squared plus x minus 40 over 5x. Okay, now let's simplify. We have what we can do from here. Well, look at it. We can always factor if it's possible, because remember that same denominator, we add the numerator. So there is nothing we can do here except because we cannot simplify any further, we're gonna keep it that way, but we know x cannot be equal to 0 in the denominator. When you look at the second one, again, here you only have one term, okay? So if you have one term in the denominator, first of all, we need to find the least common denominator, which we do. What is the least common denominator here? Okay, one term of each. So look at the 10 and look at the 4, because we need between 10 and 4. That's the first thing to do, because both rational expressions are undefined for x equal to 0. We know that already. X cannot be equal to 0. If we need to look for the least common denominator, we have 10x cubed and 4x squared. We need to list the factors. What are the factors of 10 and 4? Look, if I look at, I know already x cubed and x squared common factor is x squared, but let's go for 10. 10, we know the factors are 1, 2, 5, and 10. Factors of 4 are 2 and 2, okay? So what we know here, right? We know that if you multiply them, it's make it more difficult, because you cannot say 10 divide 4. So what I'm gonna do, we know, for example, I can rewrite as a prime factorization 2 times 5, and I can multiply by 2 times 2. So the closest number you can think of, right, is 20. Okay, 20 is the one that divides both 10 and 4. Or you can, if you don't want to do prime factorization, you can the multiples. So for 10, you can do 10, 20, 30, 40. For 4, you can do 4, 8, 12, 16, 20. The least common, the one you find the first, is the 20. So you know it's going to be 20. So that means 20 x squared is the common factor, okay? 20x cubed, because x cubed is the least common multiples, because you need to take the one with the highest degree. X cubed is the common factor. Now, make 1020, you multiply it by 2. That means you're gonna multiply this one by 2. make this one 20, you multiply by 5x. So you're gonna multiply by 5x. Okay. The top one would give you 2 times 7 is 14 over 2 times 20x cubed. 5x times 5 is 25x over 20x cubed. Remember, same denominator, it's going to give you 14 plus 25x over 20x cubed. X cannot be equal to 0. We need to remember that x cannot be equal to 0, because if x is 0, the denominator would be undefined. These two examples, as you can see, they are, these two examples have only one terms, but we can also have examples with two terms at the bottom. So let me erase this one very quick. Yes, we put it, I need space, okay? All right, let's do the second one first. Okay, the second one, the least common denominator here, as we said, least LCD, we take the first factor and multiply with the second factor. That's it. So that means in the first one, we need to multiply this one by x plus 3, and we multiply this one by x minus 3, and multiply the top one by x minus 2. Whatever you do with the bottom, you do it with the top. So meaning we have x times x plus 3 over x plus 3 times x minus 3. That's the denominator. Up, we have x minus 1 times x minus 3 over x plus 3 times x minus 3. Focus in your numerator because for now, we know that the denominator is the same and the sign in the middle is positive. So it's okay just to write x plus 3 times x minus 3, same denominator. We can add the numerators, but let's distribute. X times x give you x squared. X times 3 give you 3x. We're done with the first part. Let's go with the second one. We're going to FOIL. Remember FOIL. You do x times x give you x squared. X times negative 3, negative 3x. Negative 1 times x, negative x. Negative 1 times negative 3, negative positive 3. Okay. Simplify. X squared times plus x squared give you 2x squared. Okay. If you're okay with that, that's a good example. We have 3x minus 3x is gone. Then we have only negative x left. And we have positive 3 over x plus 3 times x minus 3. Of course, remember, x cannot be equal to 3 and x cannot be equal to negative 3. That's the denominator, okay? As you can see, denominator is different. I believe I need to put this one because I need a lot of space. I'm gonna do this one also on a slide by itself. You know, I'm going to do the last one on a slide by itself. Okay. Give me a few seconds because when I select, it takes times. Okay, let's go with this one. First of all, remember, if you don't have a simplified form in the denominator, we must factor out completely the denominator. So we know this denominator, two numbers when you multiply, give you positive 25. When you add, give you negative 10 is negative 5 times negative 5. You must factor. And we have x minus 4 over 2 times x minus 5. Okay, that's the first thing I do. What is the LCD in this case? First of all, take everything from the first one. Okay, the second one, what the first one have, what this second, I mean, that expression has that the second one doesn't have. 2, because x minus 5 is already there. So we know this one gonna be with 2. All I have to do, I multiply these terms right here by 2, and I multiply these terms right here by x minus 5, x minus 5. Now, the first term is 2x minus x minus 4 times x minus 5 over the whole thing, 2 times x minus 5, x minus 5. Let's try it. We have our 2x minus, that negative must be distributed to everything. You know what? I'm going to keep it now. X times x, x squared, minus 5x, minus 4x, plus 20. Please check if you feel like you still don't get it, okay? Because we covered this part already. You can even simplify inside, that give you x squared minus 9x plus 20, okay? Over 2 times x minus 5 times x minus 5. Okay, 2x minus, parentheses, you need to distribute the negative, plus 9x minus 20 over, because we distribute the negative, x minus 5 times x minus 5. Now we have negative x squared plus 11x minus 20. If you want, you can even factor negative. But do we really need, I don't know if we have to factor negative. Is it really worth it to factor negative? Yeah, if we want to. But we have, 2. If you want, you can do x minus 5 power 2. But remember, x cannot be equal to 5. And that would be your final answer. Or you can factor the negative. Let's complete this section, so especially this chapter, by doing some complex rational expressions. Complex rational expressions, also called complex fractions. When you have a complex fractions, like, if you have 2 plus 1 over x, okay, like 3 minus 2 over x. You see, when you have these things very complicated, we call them rational complex fractions or complex rational expressions, have numerators or denominators containing one or more rational expressions. So a complex fractions must be simplified so that neither the numerator nor denominator contains any rational expressions. All we have to do is to make sure it's working, because you can have like 3 over x minus 1 plus 5 over x plus 1 over 2x plus 6 over x plus 2, okay, plus 1/2. You can have something like that. How complex it is. But you need to solve the top one first by itself and top the other one by itself. We have one example we want to do, maybe 2 examples. You know what? We're gonna start with the first one, okay? Maybe leave enough space or leave the second one for you. First of all, we're gonna focus in the numerator. Let's focus in the numerator only. What is the LCD for the numerator? The LCD for the numerator. Yes, that's 2x. So that means I'm gonna multiply this one by 2, but this one by x and by x. So for the top one, I'm gonna have 2 over 2x plus 3x over 2x. Okay? So what you see from, as I said, I like to do the numerator first. What you see here, I'm gonna have 2 plus 3x over 2x. And I'm done with that part. Okay? I'm done with that part because now I only have one fractions in the top because you cannot flip anything here. You cannot say, oh, I have a fraction divided by another fraction. I keep the first one and multiply by the reciprocal of the second one. You cannot do that because first of all, you didn't have only one fraction in the numerator. You need to simplify it and make it into one fraction. That's what I just did. Now let's go with the denominator. What is the common factor? The LCD for the denominator. Yes, 4x. So I'm going to multiply this one by 4, by 4, by x, and by x. So we're going to have 4 over 4x plus 3x over 4x. So it gives us 4 plus 3x over 4x. Remember now we have a fraction divided by another fraction. When you have a fraction divided by another fraction, all you do, keep the first fractions as is, multiply by the reciprocal of the second fractions. Now, remember, it's multiplication, right? That means you have 4x times 2 plus 3x over 2x times 4 plus 3x. Nothing to cancel out now instead of 2x because you can factor 2x. So answer here would be 2 times 2 plus 3x over 4 plus 3x. And that's it. And you know the denominator here cannot be 0. That means x cannot be equal to 0 and x cannot be equal to negative 4 over 3, right? That's it. You know what? I do one example. How about I leave the other one for you to enjoy? It's very important. I think for now you're ready to start graphing because we're gonna do some equations and inequalities, and I think you're ready for it. After we do all those reviews are all about intermediate algebra and elementary algebra. Now I think you're ready to start really doing college algebra. Let me know if you have any questions. Do not hesitate to send me an email or something. So hopefully to see you soon. Take care.